Hello everyone, welcome back to the channel. So in the last video we have started with the algebra section of our quant course and we have learned arithmetic progression till now. If you have seen that video, this whole video is going to be very easy for you to understand and it's going to be quick because the concepts are going to be the same. Just if you know arithmetic progression, understanding geometric progression is even easier, correct? So let's start with today's video, geometric progression. So, for your memory, let's start with where we started in the arithmetic progression. In arithmetic progression, we discuss that between two numbers, the difference between two numbers is always the same, and that is known as common difference. How do you get the next number? You add the common difference to the last number and you get the next number. But here the difference is not, the difference has not to be the same. Here, how do you get the next number? Suppose I start with the series as 1. They say they to get the next number. So the next number, to get the next number, instead of adding, you multiply. Suppose I multiply by 5 to get the next number. So now 1 multiply 5 is 5. Again the next number can only be get by the multiplying with the same number, that is 5 into 5 25. The next number will be 125 into 5, that is 25 into 125, multiply by 5, that is 625, and so on, correct? So this is how you get a geometric progression series. The difference between arithmetic progression and the geometric progression was there you are adding, here you are multiplying. So just comparing two videos, it will make it very easy for you to understand the difference, and also it's going to be like an active learning for you where you are comparing two things and it is going to get easier for you to understand, correct? We have also discussed the difference, two terms, that is first term. First term this is the same from where the series start. The common ratio. What is common ratio? Common ratio is R, which is the number that is multiplied to get the next number. Here in our example, the R is 5. So the first term is 1, the R is 5. I hope it is clear. So what is the nth term of a geometric progression? Correct? So again, how we did in arithmetic progression, we start with the number A. How do you get the next number? You multiply R to it, so get the second number. In the third term, you get AR, means the last term, multiply by R, so you get AR square, correct? So take the last number AR square, multiply again R, you get AR cube, and so on. So if you see, similar to arithmetic progression, the first term, second term, if it is a second term, the power of R is 1 less than that. If it is third term, the power of R is 1 less than that. If it is a fourth term, the power of R is 1 less than that. So we can say the nth term of the series is A into R with the power 1 less than n, correct? So if they have asked you seventh term, so that will be AR raised to power 6, 1 less than that. So the nth term of a geometric progression series is AR raised to power n minus 1. AR raised to power n minus 1. And again, marked it as star, means very important to remember for the exam, correct? So they have given you a series 2 into 1, 1 by 2, 1 by 4, and so on. First thing, is it a geometric progression series? So to find, what do we need to find? That is common ratio. How do you find common ratio? Dividing the second term by the first term. So between the first two terms, the common ratio is 1 by 2, means dividing second term by first term. In between these two, 1 by 2 divided by 1 is again 1 by 2. Here we have 1 by 4 divided by 1 by 2. You will get 1 by 2, and so on. So the common ratio in our case is 1 by 2, correct? The first term of the series is 2, correct? So the first term of the series is 2. The common ratio is 1 by 2. So they are asking you which term of the series is 1 by 64. So they have asked you that an is 1 by 64. Tell me what is the value of n. So you are simply going to use a r raised to power n minus 1 is 1 by 64. Do the calculation please and you will get the answer. So if you want, I can do this one for you. I'm just erasing this, correct? So A is 2, R is 1 by 2 raised to power n minus 1, that is 1 by 64, correct? So taking 2 on that side, that is 1 by 2 raised to power n minus 1 is equal to 1 by 128, right? Nice. So we have to calculate 1 by 2, 128, you need, this is 8, 16, 4 for 16, 16 4s are 64 and 2, that is 128. So 128 is in actuality 1 by 2 raised to power 7. 1, 2, 3, 4, 5, 6, 7. So 1 by 2 raised to power n minus 1 is equal to 1 by 2 raised to power 7. So you can compare n minus 1 is 7, n is equal to 8. So the answer is n is equal to 8, correct? So if you are not able to understand the powers, there is a video in the last section, number system, called powers. You can understand how to handle the powers in fractions. Correct? This is easy. N is equal to 8. Moving on. Like arithmetic progression, there is a sum of n terms of a geometric progression. And the formula for that, I am just giving you the formula directly. That is Sn is equal to A r raised to power n minus 1 divided by r minus 1. And those who want to do the active recall in arithmetic progression, the sum of n terms is n by 2 2a plus n minus 1 into d. You can do however you want to remember. So this is the formula for n term of a series, n terms of a series in a geometric progression. A r raised to power n minus 1 divided by r minus 1. I hope it is clear. And what was the nth term of a arithmetic progression series? Nth term of an geometric progression series is a r raised to power n minus 1. Correct? So these two things you need to remember again and again. I am emphasizing that you need to know these formulas for the exam. Right? Now starting with this. If a is 3 and r is 2, give me the sum of first 5 terms of GP. First thing is, can you form this geometric progression series? Yes. So first term is 3. How do you get the second term? 3 into 2, that is 6. 6 into 2, 12. 12 into 2, 24. 24 2 and 48. 48 into 2 is 96 and so on. Right? So they are asking you to give me the sum of first 5 terms of the series. You can use the formula Sn is equal to A r raised to power n minus 1 upon r minus 1. A is 3. What is common ratio? 2 raised to power n. N is raised to power 5 minus 1 divided by 2 minus 1. Whatever is the answer, that is the answer you want. Correct? This is easy. You just need to remember the formula. Then only you can find the sum of first 5 terms of a geometric progression series. Now, it's also possible that a series is given to you and you can find the sum of infinite term of that geometric progression series. Infinite terms. See, I don't want to get into the details. That is going to be like out of scope for this exam. But I can show you the difference how we can do the sum. Suppose the sum of an geometric progression series is given like this. 2, next term is 4, 8, 60, 32, 64 and so on. If we do the summation of such a series till infinite, you are surely going to get infinite. Why? Because every number, with each passing number, the number is increasing and increasing. So, adding such infinite numbers is going to give us infinite as the answer. So, sorry for that. So, there is a type of series. If such a series is given to you, you can find the sum of geometric progression or sum of those numbers. Let's see. Suppose the first number is 1. Next number, the common ratio is 1 by 2. So next number will be 1 by 2. Third number is 1 by 4. Next number is 1 by 8. 1 by 16. 1 by 32. So here the first term is 1. The common ratio is 1 by 2. So you will see here the first number is quite big. Then the number is halved. Then the number is halved. Then the number is halved. Halved, halved, halved. So it's getting smaller and smaller and smaller. So the such series, you can say, can say that since the series is decreasing and decreasing with each number, I can give the summation of infinite terms of such a series. Infinite terms of such a series. And how to do that, we'll see. But first thing, how to find such series? So, to find the infinite terms of a geometric progression series, the condition is that the common ratio between two numbers can only be this is the thing. So the common ratio can only be between minus 1 and 1. Minus 1 and 1 means, because the common ratio cannot even be equal to 1 or minus 1. Cannot be equal to 1 and minus 1. The only thing is they have to be less than 1 and greater than minus 1. Why? Like suppose 0.9, 0.7, minus 0.2, minus 0.5. Only these ratio between 1 and minus 1 are allowed. Why? Because multiplying with such a common ratio, the numbers or the series start getting smaller and smaller instead of increasing. So, in only in such scenarios, we can do the sum of infinite term. So, if someone asks you, give me the sum of infinite terms of a series, so what do you need? You need to know that the ratio has to be between 1 and minus 1, and they can also not be equal to minus 1 or 1. That is also not the case. They have to be less than 1 or greater than minus 1, and only between this band. This band means minus 1 and plus 1 and 0. Only between, not even equal to minus 1, only between here. Only between this part is only allowed as a common ratio and nothing else. If this is the case, then you can say such a series has, the formula for such a series of infinite term is of a upon 1 minus r. Please note it down. Sum of infinite terms of series is possible, and that is a upon 1 minus r, but 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 the common ratio has to be less, greater than minus 1 and less than 1. So suppose they have given you series as 1, 1 by 2, 1 by 4, sorry, 1 by 4, 1 by 8, 1 by 16, and so on. Can you find the sum of infinite series? Yes. Why? Because the ratio is 1 by 2, which is in this range. This range. So, if since this is in this range, yes, sum of infinite term is possible, and that is a upon 1 minus r. So, the answer you are going to get is number 2. So, the answer of, or the sum of infinite terms of this series is 2. So, please remember, you don't need to remember only that formula, you need to remember the condition. They could ask you a trick question. They have, suppose the ratio they have given you, common ratio you find is 8. For such a series, infinite term summation is not possible. You can directly say that the question is not correct, or option D is the question does not have an adequate data. So such trick questions could be solved if you know the condition that r has to be minus 1 and 1. Now I have spent a lot of time on this infinite terms of geometric progression. I hope you are able to understand. Again, if you're not, please rewatch this part. And if you have any doubt, please post them in the comments. Or you can join us on our Telegram channel. You can post it there. So we'll get back to you as soon as possible. Correct? Now, next coming to the geometric progression part. So this question is given to you. Find me the sum of this series 5, 55, 555, 5555, and so on. First thing, is it a geometric progression series? Let's see. 55 by 5 is 11. 555 by 55 is not equal to 11. So in this series is not a geometric progression series. But why I have kept it as geometric progression series? You need to just do simple formatting, then make it a geometric progression series. How? Let's see. Such question have been asked in the previous year question, and this is one of the examiner favorite. They can give you 9 plus 99 plus 9999 and so on. Don't worry, now we know the trick. S is this. Now take 5 out of this. So if you take 5 out of this, you will left with 1 plus 11 plus 111 plus 1111 and so on. Correct? Now the next step is multiply everything by 9. 9 plus 99 plus 999 plus 999 and so on. Why I am doing this? These are fixed steps, right? First take out 5, so you will be left with 1, 11, 11, 11 and so on. But since this is also not geometric progression series, this is not even GP right now. So we need to do further formatting. So multiply and divide by 9. You will get 9, 99, 999 and so on. But still again, this is also not a geometric progression series. Why? 999, 999 is still not a geometric progression series. What do we need to do next? S is equal to 5 by 9. How we can write 10? 9 as 10 minus 1. Can you write 99 as 100 minus 1? 999 as 1000 minus 1 and so on. And just take all the tens in one side, that is 10 plus 100 plus 1000 and so on, and take all minuses, all ones on one side. 1 plus 1, these ones are how many times? N times, N times. I hope it is clear. So if you see now, this is, what is this? This is a geometric progression series. Yes. Why? Because the first term is 10 and the common ratio is 10. So now we have a GP. So the summation of such is a r raised to power n minus 1 divided by r minus 1. So you just put in r as 10, a as 10 and n as n, because they have asked you the sum of n terms of the series. Minus 1 plus 1 plus 1 n times is simply n. So the answer you are looking for is 5 by 9. So whatever you get from this part, a r raised to power n minus 1 upon r minus 1, I am just leaving it for your calculation, minus n coming from the second part where we have added n times 1. So this is the final answer. This is an important question, have already been asked in the CSAT exam. So please, if you have not understood it, just rewatch it. So the examiner is simply going to ask you 3 plus 33 plus 333 plus 3333 and so on. But all are the same. You just take out 3 out of it, like we did 5 out of in our question. But the, but the trick is the same. You need to know what are the steps, and any number they ask you, you will be able to solve it. Right? Now, this is next part. Next question. The third term of a GP is 4. The third term. How do you calculate the third term? A r raised to power n minus 1, or you can say a r square is 4. This is given to us. Give me the product of first 5 terms. Product of first 5 terms. This is not sum. So the first 5 terms will be ar square, ar cube and ar4. So they want the multiplication of all 5 terms. So to multiply all 5, you just add the power of a, that is 1 plus 1 plus 1 plus 1 5 times, and r is add all the power 4 plus 3 7 plus 2 9 and 10. So this is the answer you get, a raised to power 5 and r raised to power 10. Taking 5 common out of it, a r square raised to power 5. We know a r square is 4 raised to power 5, and this is the answer you are looking for. Correct? So if you know a raised to power n, an, sum of n terms, sum of infinite terms, you need to know the formula. Then only you can apply those tricks in this question. Suppose if you don't know this part, how can you even imagine to solve such a question? Correct? Now, moving on to the last part of this video, that is geometric mean. And I'm going to make it quick because you already know one geometric mean between two numbers. Suppose 3 and 81 are two numbers. They are asking you insert one geometric mean, that is G. Now, if this is a geometric mean, G is a geometric mean, this series will be a geometric progression. So, the common ratio, that is G divided by 3 is equal to 81 divided by G. Correct? So, solving this, you will have G square is equal to 81 into 3. So, whatever value of G you get, that is the answer. Correct? This is how you can find the one geometric mean between two numbers. And if you want a formula like arithmetic means, so one geometric mean between two numbers a and b is given by under root ab. This is the formula you need to remember. But only when they have told you that there is one geometric mean. But if there are more than one geometric mean, that is not possible. And to solve this, you need to know all the gn method and all so on. So if they say there are 5 geometric mean between this G1, G2, G3, G4, G5. So now to find this, you need to know A, you need to know D, and how will you get it? You can solve this. Correct? So let's see. There's a question given to us that between 3 and 48, there are 3 geometric means G1, G2, G3. First thing is done. We know that first term is 3. How many terms are there in the series? 5. 1, 2, 3, 4, 5. Do we have common ratio R? Still no. But we know that nth term of the series is 48. And the formula for nth term is a raised to power r minus 1. So 48 is equal to a, that is 3, r is r, and n minus 1 is 5 minus 1, 4. So you have 3, 16 is equal to r raised to power 4. So solving this, you will have r as 2, because 2 raised to power 4 is 16. So r is 2. So r is 2 you are looking for. To get G1, simply multiply it by 2, means r, you will get 6. Multiply 2, you will get 12. Multiply 2, you will get 24. And multiplying 2, you have 48. So these are the geometric means you are looking for. Correct? So I know AP and GP took some time, but believe me when I say that these topics are really important from the exam perspective. So please don't take them lightly. Again, like we did a review, I'm going to write the formulas for geometric progression series. Nth term of the series is a r n minus 1. Sum of n terms of the series is a r n minus 1 divided by r minus 1. Sum of infinite terms of the series is a upon 1 minus r, given r is greater than minus 1 and less than 1, and also r cannot be equal to 1 minus 1 and r cannot be equal to 1. Fourth part, one geometric mean between two numbers a and b is given by this formula. Fifth part, if there are a and b, two numbers are given to you and you need to insert g1, g2, g3 and g4, you can find this the way we did in the last question. Correct? I hope this video was helpful for you. So please keep practicing. This video was very similar to what we have learned in the arithmetic progression series. So I would say we watch both of these video together if you have not watched the first video. So that's all for today's lesson on geometric progression. If you think this has helped you, please share this video with your fellow aspirants, and please subscribe to our channel. This really motivates us, and please feel free to post your doubts or feedback in the comments. These really keeps us motivated to pursue with this series. So let's meet in the next video. Till then, please keep practicing and keep learning. Thank you. We'll meet in the next video.